Academic 7.5 notes, how to rationalize denominators. Where's my pencil? Here it is. All right, so 7.5 notes, okay. So far in this chapter, when we've been writing our answers, we've been leaving, so let me look at these other notes, see if I can find an example. Right? We've been totally fine leaving square roots on the bottom, right? So let me find an example. Are there any examples here? Oh, I guess there aren't many examples. Okay. I guess there aren't any examples, okay? But so far, one other thing, so when you are doing a problem like this, let's say you're simplifying a radical or adding or subtracting radicals, okay, or multiplying radicals, okay? When you get your final answer, you cannot have a radical in the bottom of a fraction in your answer. Okay? Let's pull it up somewhere. Okay, you cannot have a radical in the bottom of a fraction in your answer, okay? Can't have it. It's bad. It's bad. It's bad. It's bad. Okay? Can't have it, okay? Mathematicians just don't like them. They just don't like them. Okay? All right? So here's how I do it. This is pretty straightforward. Learning objectives, 1. Rationalize denominators. Okay, pretty straightforward. So what I do is, okay, first I look at the number that's outside the radical. On a square root, it's technically what? 2, yeah. So note the number outside radical. And then what you're going to do is, I don't know how to articulate this. You're going to multiply the bottom of the fraction by that many of that number. With the radical symbol included. Just 2 little steps here, okay? Okay. So on this one, right, my number outside my radical is 2, right? So on the bottom of my fraction, I need to have 2 root 5s. And I accomplish that by multiplying, I should say bottom and top. Sorry, bottom and top. Okay. So I have a square root. I have a 5 that's rooted to the second, to the 2. So I need to have 2 root 5s in my denominator. So what I do is I multiply by root 5 over root 5. Okay? You have to multiply the top as well. Why is that? Anyone know? Okay, in algebra, you're not just allowed to suddenly multiply by 1 over root 5. You can always multiply something by what without changing its value? 1. You can always multiply a number by 1 without changing its value. So instead of multiplying by 1, we are multiplying by 1. We're multiplying by something over itself, right? What's a number divided by itself? It's always equal to? 1. Yeah, so we're just multiplying by 1, basically. Right. So root 5 times root 5, we're multiplying by 1. So that's why you have to multiply both the top and the bottom, okay? Right? So we multiply this across, we get 3 root 5 on top. On the bottom, what do you think is going to happen?
2 root 5.
We're going to have a root 5 squared, right? What's root 5 squared?
5.
Just 5, right? That cancels 3 root 5 over 5. Did you guys do that in Algebra 1? Or geometry? You didn't? Oh, no. Okay. It was the COVID year. For Algebra 1.
That's the answer?
Yeah, that's the answer. Yeah. 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 Pretty good. Where's Sophia? Can I move on to B? Okay. We've talked about this before. How do I do the square root of a fraction? How do I do the square root of a fraction? You can always just break it up, right? So it's the square root of 1 over the square root of 7, right? What's the square root of 1 on top? 1. So we have 1 over root 7, right? What's wrong with that answer? What's wrong with that answer? It's a radical on the bottom, okay? What? That 7 is rooted to the what? To the 2, right? So I need to have 2 root 7s in my bottom here, okay? So to get the other one to appear, I multiply by root 7 over root 7, okay? All right? Multiplying across the top, right? 1 times root 7, that's just root 7. The bottom's going to become root 7 squared, right? What did that square root and that square do? Cancel. Yeah, so this becomes root 7 over 7. Final answer, okay? Feeling okay so far? So we can't have radicals in the denominator or in the bottom of my answer, okay? This is how we get rid of them. Or, yeah, this is how we make sure there's no radicals in my denominator, okay? You guys need to do this next year a lot. Okay. Can I move on to C? All right, C's the same thing, right? Instead of a square root of that whole thing, I do what? I break it up. Okay. What's wrong with this answer? It's got a radical in the bottom. All right. What's that? What kind of radical is that? It's a 2 root. It's rooted to the second. Okay. So I need to have how many square root of 2's in my bottom? 2. So I'm going to get that second one by multiplying by root 2 over 2. Okay. What does the top simplify to? Root 5 times root 2.
Root 10.
Root 10. Okay, good. And the bottom becomes what? 2, yeah. Hopefully you can see by now. It's starting to become self-evident that that's 2. Root 2 times root 2 is 2. Okay. All right. Good stuff. Okay, so that's like the basic concept. It just gets a little more complicated when we move into other stuff, more complicated things, okay? So right here, right, we're going to break up that square root. Okay. What am I going to multiply the top and bottom by? Yep, so it's a second root. So we need to have 2 root 2b's in the bottom. So I'm going to multiply the top and bottom by square root of 2 times b, 2b. Okay. What does the top become here? Yep. So what we do is we multiply the top 2 numbers together, and we keep them under the square root. Okay. On the bottom, root 2b times root 2b is what? Just 2b, right? The square root goes away, okay? And then this is going to start to become an issue. At this point, make sure your answer is simplified. Okay, is my answer simplified? Is it not simplified? What can I simplify?
You go back down to 23 or not?
No, I can't. I like the thought, though. If I try to do, okay, so you guys think you can simplify root 46? So 46 is 2 times 23. Okay. So then root 46 is square root of 2 times 23, which is root 2 to the 1, second root of 2 to the 1 times second root of 23 to the 1. Can I simplify either of those? No, right? My inside number is smaller than my outside number. So root 46 stays as is. In radical form, this is simplified all the way. Yeah. All right. Okay. So let's go ahead and break it up. So root 16x to the 5th y all over root 4z. Okay. Hopefully you guys are picking up on this. What am I going to multiply the top and bottom by? Root 4z, right? I just do it one time. Right? Because I only want to have 2 4z's in the bottom because I have a 2 root. I'm rooting it to the second power. It's rooted to the second. Okay. So the top becomes what when I multiply these two numbers together? 64 x to the 5th yz. Make sure you have the square root symbol still. Okay. The bottom becomes what? Just 4z, right? Okay. So we don't have a radical in the bottom, okay, so that's good. But we do need to make sure our answer is simplified. Is this simplified? No, yep. So I can break the top up into root 64 times root x to the 5th times root z. Okay, what's root 64? 8. So I'm going to erase that and put an 8. What does square root of x to the 5th become? Yeah, so 5 divided by 2 is 2 remainder 1, right? So it's going to become x squared root x. All right? And then root z, can I simplify that? No, right? Its exponent, its inside number, is smaller than its outside number, okay? All right, and then multiply these two guys together. So your final answer is 8x squared. That's actually not the final answer. Sorry, I just realized something. You can simplify this one more thing. Sorry. One more thing. The z's cannot cancel. That's a great question, though. The z's cannot cancel, okay? If they would cancel if there were a z in the bottom and a z in the top. We don't just have a z in the top, right? We have a what? Square root of z, so they're not going to cancel. Okay? But the 8 divided by 4, does that simplify?
Yes.
8 over 4 to 2, yep. So my final answer is 2x squared root xz all over 2z. Is it a y? Sorry. That's my final answer, okay? So there can kind of, yeah.
Got the x as well.
Oh, there's an x. Oh, x, okay. Thank you, sorry. So there can kind of be a lot going on here, which is why I kept forgetting stuff. Right, but we're doing the same things over and over, yes. Did I forget a y?
No.
It's right here.
Do you get rid of the 2 at the bottom or no?
Yeah, why did I write a 2 there? Sorry. I just totally derped. Sorry. Yeah, 8 divided by 4 is 2, just a 2 on top. 8 divided by 4, you leave the, which equals 2, you leave that 2 on top. So sorry. Period E. Maybe I can shoot a better video during period E. Okay. This is a little bit of a respite. F. Letter F here. Okay, can't have a square root in the bottom, right? So I'm going to do what here? So I'm going to multiply it by root 18x over root 18x. Since it's a second root, it's rooted to the second. I want there to be 2 root x's in the bottom, okay? So the top becomes 5 root 18x. The bottom becomes 18x. Can I simplify anything? I can, yes. So I have no radical in the bottom, which is good, but my answer also has to be simplified all the way. Am I simplified? Are my radicals simplified here? So I can't really simplify root x. Can I simplify root 18? I can, yep. If we break 18 down, we can break that into 9 times 2, 3 times 3. So the square root of 18 equals the square root of 3 squared times the square root of 2, or just 3 root 2, okay? So that becomes 5 times 3 root 2x all over 18x, or 15 root 2x all over 18x. Okay? Am I simplified? No, I'm not.
You're still not.
You also, at the very end, I think you're on the right track. You gotta make sure that the two numbers, that's not really showing up that well on the, oh, I turned the brightness up. My highlighter's not really showing up, is it? I'll use a purple highlighter. It's still not great, but oh well. Okay, so these two whole numbers that you have at the end that are outside of everything, you gotta treat those like a fraction. Is 15 over 18 a fully simplified fraction? No. Simplifies to 5/6. Okay? So my answer is 5 root 2x all over 6x. I'll use an even darker, I'll use a black highlighter. Oh, there you go. It shows up as gray on the board. It kind of shows up as black. What the heck is going on out there? Okay. Can I move on to G? What do I do with G? Yeah. Yeah. All right. I got to multiply the top and bottom by what here? Root 11. Yeah. So it's going to be negative. What does the top become? Negative 7, and then that root 3 times root 11 is what? Root 33. Yep. Bottom is just 11. Okay. This one's a little better. I can't simplify it at all, right? Right. If I were to break 33 down, I'd just get 3 times 11, but neither of that's squared, right? So the square root's not going to cancel, so. All right, and then 7 over 11, is that a simplified fraction? Is that in simplest form? Yeah, okay. All right. Ooh, fancy. I do the same thing, though. I do the same thing, okay? So I can't have a square root in the bottom, right? It's a square root. Since it's a square root, right, the number outside the radical is 2. So I want to have 2 square root of x's, okay? So I'm going to multiply the top and bottom by the square root of x, okay? What's different about this problem?
The top just leaves with that.
The top has 2 terms, right? So when you multiply on top, make sure you put parentheses around both your terms, because you need to distribute that root x to both of them. Okay. I don't do 3x. Yeah. You won't get the wrong answer as long as you simplify everything correctly, but it's just extra work. Okay, so we're going to FOIL the top, so that, or we're going to distribute the top. Root x times root x is what? X. Okay. Root x times 2 root y plus 2 root xy. Okay. And then on the bottom, what do I get? 3x, yep. I'm not completely sure if this is how this wants us to do, because this can be simplified.
Can we cancel the x, right?
Can you do that? Can I do that? I can't do it here. Why not? Well, I can't do it without doing something else first. I have a plus sign in the middle, right? In general, you can't really cancel stuff when there's a plus on top of your equation. You can only cancel things that are separated with multiplication symbols. Okay? But I can make it so I can cancel it. What do I do first? Anyone know? I can split up my numerator, okay? So right now I have x plus 2 root xy all over 3x. I only wrote my denominator one time. That's equivalent to just doing x over 3x plus 2 root xy over 3x, okay? Those are the same thing. I can always split up my numerators. okay? I just write the left term over the denominator plus the right term over the denominator, okay?
And the x's cancel.
Then the x's cancel, right?
Then what do you do about the other side?
I leave it.
Ah,
Yep,
and that's technically more simplified than.
I think it is. I think it is, right? So I have no radicals in my bottom, either of my bottom. Good, right? I can't pull anything out of this square root to simplify it, right? I can't do that, okay? I'm simplified. All right, now we got to change things up a little bit, okay? So with part I have a cube root of 2 in the bottom, right? Can't have a radical in the bottom, but now that the outside number is 3, I need what on the bottom?
You have to multiply it by.
I need to have 3 cube root of 2's in the bottom. I need to have 3 cube root of 2's in the bottom, okay? So we're going to multiply the top and the bottom by cube root of 2 times 2. All right. You guys see how it's a little different this time? Now I need 3 2's, 3 cube rooted 2's in my bottom. Because I have a 3 on the outside, okay? You good? All right. So on the top, that multiplies to what? 7 times 2 times 2. 28. Okay. On the bottom, what's going to happen to my bottom? I'm going to get cube root of 2 cubed. Because I have the number outside my radical in the bottom is 3. So I need to have 3 2's. 3 of them in the bottom. 3 cube root of 2's. What's that? Yes. What?
Why is it multiplied by 2?
What do you mean? Okay, I could technically also do, would it be easier if I did cube root of 2 times cube root of 2? That's what I did. Why just 1 cube root of 2? Yeah, so in general, the instructions were, if you have whatever number you have at the beginning of the problem, we had a 3 outside of our radical symbol. We had a 3 outside of our radical symbol, okay? That means to cancel that radical, we need to have 3 cube roots, okay? If I were just to do cube root of 2 times cube root of 2, that would not cancel the radical. I need to have 3 2's at the bottom. Yeah.
Could you technically do cube root of 2 squared?
Yeah, which is what I did. Yeah. So I need to have 3 2's in the bottom because there's a 3 outside my radical. That's my short answer. Okay? Yeah. Right? By doing all 3 of those 2's, right? 2 times 2 times 2 is 2 cubed, right? That cube lets me cancel. A cube and a cube root cancel. Right? So then I'm left with cube root of 28 all over 2. Okay. So I have no radical in the bottom. Is my top simplified? Can I simplify that at all? You can always check. You can always check to see if you can simplify. Right? So cube root of 28 is cube root of 2 squared times 7. Do either of those have exponents bigger than 3? No, so I can't simplify that at all. This is my final answer. Okay. All right, let's do number G, and then I got to move on to the back, okay? Let's do number G. Okay. So I have a 3 outside. I can't have a radical symbol in my answer. I have a 3 outside that radical symbol, right? So how many cube roots of 5y to the 4th do I need? 3. I need 3 of them in the bottom. So whatever I do on top, on bottom, I also have to do on top. Okay. So the bottom's going to become what?
5y to the 4th.
Just 5y to the 4th. Are you guys seeing a pattern? What you end up getting on the bottom is just the same thing you had, just stripped of its radical. Yep.
Will it always be like that?
Yeah. The top, you're going to get 10x times 5y to the 4th times 5y to the 4th. That's what? 250x y to the 8th and cube root of all that. Okay, on top. Can I simplify that cube root? Cube root of 250 does simplify, so that's what? So this is going to simplify to cube root of 2 times 5 cubed, or cube root of 2, oh come on, cube root of 2 times cube root of 5 cubed, which is 5 cube root of 2, okay? Is this guy in the middle going to simplify? No, right? The number inside's too small. What does cube root of y to the 8th simplify to? Is that y squared, cube root of y squared? Yeah. Okay. So the top becomes 5y squared times the cube root of 2xy squared all over 5y to the 4th. And again, make sure, is this fraction here, is that simplified all the way? No, right? The 5s are going to cancel. And then what happens to my exponents? Y squared over y to the 4th becomes what?
Y squared gets dropped on the bottom.
Yeah, just a y squared on the bottom. Okay. All right. Let's move on to the back, okay? Now what do I do here? What's the difference here?
Multiple terms on the bottom.
There's multiple terms on the bottom, right? So I have to do what? What do you think I'm going to do? Now to rationalize, I'm going to do what? I'm going to multiply the top and the bottom by the conjugate. Okay? So if I have a number root A plus B, what is its conjugate? Do you guys know what its conjugate is?
Isn't it 1 over...
It's going to be root A minus B. So these are what we call conjugates. You just flip the sign. Okay, so you just flip the sign, okay? You guys got that written down? Okay. So I'm going to multiply the top and bottom of this first problem by what? What's the conjugate of the bottom here? And I'm going to use parentheses. It's going to be root 5 plus 4. Okay. So I'm going to distribute the top. Okay, so 2 times root 5 is 2 root 5. 2 times 4 is 8. On the bottom, I'm going to FOIL. I will say, when you FOIL the bottom, okay, when you multiply by the conjugate, something by its conjugate, you FOIL. But the outer and inner products are always going to cancel. So you kind of just do Florida. Okay.
Yeah.
Right. So if I do first, root 5 times root 5 is what?
Root
5.
5 squared.
Yep. Then this is going to be plus 4 root 5 minus 4 root 5 minus 16. Okay. Do you guys see what's going to happen in the middle? When we combine like terms, those cancel. We just get 5 minus 16, or negative 11. Okay. Negative 11, okay?
That's simplified.
Yeah, that's simplified. Right? Can we pull anything out of my square roots? No. I will say, you need to make sure these three numbers don't have any common factors. That's kind of annoying, right? So I think the easiest way to simplify these in general is to split up your numerator. So rewrite this as negative 2 root 5 over 11 minus 8 over 11, okay? And then just make sure these two fractions here are simplified. 2 over 11 and 8 over 11. Is that in simplest form? Yeah. Okay, that's going to be the easiest way for you to do these, to simplify, okay? All right. Let's skip down to C. Can I skip down to C? We're almost out of time. So I'm going to do multiply the top and bottom by what?
Conjugate.
Yeah, so root 3 minus root 2 over root 3 minus root 2, okay? Okay, so let's FOIL the top. What's root 2 times root 3? It's going to be root 6. What's root 2 times minus root 2 is going to be minus 2 plus root 12 minus root 8. Okay? And on the bottom here, right, my outer and inners will cancel, so I just have to do first and last. So that's going to be 3 minus 2 on the bottom. All over 1. It's going to be all over 1, and that I can just ignore that, okay?
Why is that all over 1?
Because 3 minus 2 is 1. Yeah. Okay. And then to simplify this, I just simplify all of my square roots. So that's a root 6. That's already simplified. What does root 12 simplify to? 2 root 3. What does root 8 simplify to? Yeah. Do I have any like terms here I can combine? So for there to be like terms, they have to have the same exact square roots. They have to be the exact same in everything. Okay, same inside number, outside number, same like base or whatever. Let's do one more, then I'll give you your homework. Let's do D real quick, okay? So what's my conjugate here? Plus root y. Alright guys, bear with me for a couple more minutes. Okay, so put parentheses around everything and FOIL. Okay, let's FOIL the bottom first because it's a little simpler. So it's just going to be first and last. Since, right, the outer and inner are going to cancel because we're multiplying two conjugates together. Okay, 3 root x times 3 root x, what's that? Right, that's going to give me, multiply the 3's together, you get 9. You're going to get root x squared, which is just x. Okay, so that's going to be 9x. And then minus root y times root y is a minus y. So that gets rid of our square roots in the bottom. Okay, on the top, we're going to have 3 root x times 3 root x, which we just said is 9x. Outer is going to be plus 3 root xy. Inner is going to be minus 6 root x. Last is going to be minus 2 root y, okay? And that's it. None of these terms in my numerator are like to each other. Why is that? None of them have identical square roots, okay? There's a root y, there's a root x, there's a root xy, and there's an x, okay? For them to be like terms, they have to have the same variables with the same radical symbols. The same everything, okay? All right, good work today, guys.
Where'd you get the negative y from?
On the bottom,
Yeah.
I did first, last.
Yeah.
Minus root y times plus root y.
Wow. Okay. But then,
That's going to be minus root y squared minus y. Okay, homework for tomorrow. Get pictures of the textbook. It's right in front of Ava. Page 752. Get pictures of page 752. That's your homework for Friday.